So, this is our first SafeStack webinar of 2024, and hopefully it'll be something of a monthly event. So I do hope you will come back and join us again. My name is Laura Belmain. I'm going to be your host today, and today we are going to be getting into the really important subject of developer culture and its relationship to us as security leaders and how we need to think about our strategies. Now, if you're expecting the standard developer security talk where we say that everyone is lazy and silly and that they could do better, but they don't, this is not that talk. This really is a from the ground view of what life is really like in software development right now and how that's going to impact your decisions, or how it should impact your decisions when it comes to planning your AppSec program. So, without further ado, what are we going to cover today? Well, we're going to do four things. We're going to have a look at a bit of a health check for dev teams all around the world. We're going to have a look at DevSecOps versus developer productivity, why this matters right now, and why the age of DevSecOps could be on the way out. We're going to look at no code and low code and AI, but not in any huge detail, but more in a where do these fit in your world right now? You might be surprised, they're probably in more places than you imagine. And we're going to talk about some blind spots in our pipeline. So as I said, this is a bit of a kind of a view, an overarching view of where development is today in 2024. And it's based on my experience and a large global survey that SafeStack has been carrying out now for the last 6 months. So I hope there will be lots of value for you today. If you have any questions, please feel free to pop them in the chat box below. I'll check in regularly just to see if there's anything we need to add. And if you need to follow up at the end, my details will be available on the last slide. Right then, so for those who have not met me before, that's a lot of words on a slide. Don't bother reading them. It's really not a great idea. My name's Laura Belmain. I am the CEO and founder at SafeStack. I've written a couple of books you may or may not have seen: Agile Application Security, which was published by O'Reilly, and Security for Everyone by Holloway. And I have done a few things in my time, speaking at a lot of conferences, so you may have seen me around the place. But the key point of this is that I've been doing this a very long time. I hide the grey hairs now with a lot of hair dye, but we're talking 20 years plus in both software development as an active contributing developer and as an AppSec specialist. So that's my background and where it relates to all of this. So let's get into our dev team health check. Right, what are we doing? Well, we're going to look at the health of our dev teams. Now, first things first. I don't want us to live into any delusion that software is really organized and structured. Software, as we know it, is beautiful chaos. It is made up of dozens of software languages, versions, platforms, libraries, frameworks, and they change frequently. Now, I don't know anything about your background, you who are watching this or joining me today, but our security approaches are going to need to work for every single stack. Now, this is a bit of a visualization of commonly used programming languages, and I like it because it's a really simple way to understand what I mean here. Now, I've been a contributing developer since 2005-ish, so even this diagram doesn't go back far enough for me. But if you look at 2018, our predominant language out there in the world was Python, which, to be honest, shocked me at the time because I would have thought it still would have been, the .NETs and Javas of the world. But no, Python was by far the most prominent. Now, over time, this has shifted. This has shifted towards our JavaScript languages. Now, if you've been running an AppSec program, you'll know this. You'll know that you're seeing a lot more TypeScript, a lot more Node, a lot more raw JavaScript in the world. Does this mean that we can only focus our security on these new emerging technologies? No, it means actually there's a complexity to what we're building that is infinitely changing. So if you work in a giant bank right now, you've probably got a bit of all of this somewhere in the mix. There's probably even a bit of COBOL if you're lucky. If, however, you're in a smaller, earlier stage company, perhaps your list is smaller. But what I can promise you is it will grow with time. So we need to make sure whatever our application security approach is, it's not tied to a specific language or framework, because that's going to be really, really dangerous as we go forward. The other thing we need to be really aware of is our development community are already managing a great deal of aspects of software. So it isn't really just about writing code for them. It is about what they call the illities. So these are things like performance, scaling, usability, accessibility, observability, making sure that the quality of that code is high. So when we're talking about software and software quality, it's much, much more than does it meet the functional requirements. And this is a language that is already and commonly used throughout our development teams. What we need to be ensuring is that security is in this list. It's not separate from it. It is part of the same language that is already being used. Now let's talk about our development teams themselves. What are we seeing out there? Well, there are an estimated 30 million software developers globally, and that's growing at a rate of 1.2 million per year, which is great, really positive. To be honest, I can't comprehend how many people 30 million people is, but have a look at your world. You'll probably have seen growth over the last decade or so. And it is a truly global community. There are high growth companies that we're very aware of in places like the US. You can't help but know about the Silicon Valley unicorns. However, did you know that Indonesia has a massive burgeoning software community that has companies at the same scale or bigger, but they only have to sell inside their own country because of the population. So it is a truly global workforce, and the most likely workforce to be happy and thriving in a remote world. Now, that's the positive side of this. However, we can see threats emerging. We can see pressures. Now, you will not have missed, I'm sure, that last year we had 262,000 publicized layoffs in technology across software development roles. And so far in 2024, we're aware of an almost 43,000 more. Now, it's only the 27th of February where I am, which means that that rate is looking to be very, very high in 24 once again. Now, what does that mean? It means that burnout and stress are number one themes of the community. Now, this isn't just speculation. You can look at the talk tracks on popular development conferences around the world. They almost all have now tracks on surviving burnout, on managing stress, on keeping your job in a high-profile environment or in a struggling economy. This is not a happy time for development teams. They are feeling consistent and growing pressure. While their team sizes are reducing and often their budgets, their workload has not. There has been no change in the expectation that we want to be doing as much as we were before. So what does this mean for us? Well, it means a few things. Firstly, you can't increase pressure on an already pressurized situation without there being bad things happen. The other side is it links into our maturity overall. Now, as I said, SafeStack does a number of surveys each year, and they look at the maturity of development teams when it comes to the implementation of security practices such as DevSecOps, continuous integration and continuous deployment, rolling out of tools like SAST and DAST. Now, we see that only 2% of the organizations that we've spoken to, and we're speaking to around 2,000 organizations each year, are what we call the cutting edge. So they have a mature program that is continually evolving, that engages the wider development team. The rest of us are in either fragmented exploration, so we're giving it a try, but it's not quite there yet, or we're emerging, we're just getting started. Now I'm going to back that up with a few other stats that you might find interesting. So as part of the survey that we've been conducting of these thousands of organizations, we looked at the number of software developers in the organization and how that related to the number of information security professionals, application security professionals, and the size of the entire workforce. Now, I find this very interesting because we have some assumptions in how we do our application security programs. Firstly, we assume that the large organizations have this covered, that they have the best response, and that our smallest are doing very little to nothing. We found the converse to be true. In fact, the sweet spot we're finding is medium-sized organizations between 1,000 and 5,000 people who have the best ratio we've found of software developers to application security, at 17.4 software developers per security person in application security specializations. But if you look at the larger end of town, if you are from those size of organizations, we see that number of 17.4 jump to 112.9, and that's a huge jump forward. Now, what's that mean? Well, there's two things at play here. Either we don't have the budget or time or structure that would allow us to scale application security, or, as we know is the case in our industry right now, that there aren't a lot of application security people to hire. And therefore, getting a specialist team that scales alongside your dev presence is relatively difficult. I think the days are emerging. Sorry, days are still very early for this data. We're still only a few thousand organizations. I would like to get more. But I think we're seeing some consistency here. We're seeing that for many organizations that we work at day to day, those medium and smaller, having about 40 to 50 engineers per AppSec person is normal. So if you were in a team right now that has 50 developers, you should probably be looking at your first specialist. If you are in a larger organization, I'd love for you to have a look at your ratio of software developers to application security and see where you're at. Now, I'm not saying you should hire to get to this ratio, but if you're not able to achieve even that 50 mark, as we see in the smaller organizations, then perhaps there are other techniques and approaches your strategy needs to bring into place, because scaling the human effort really isn't going to work. So the key findings I have summarized here, and I'll be sharing this video and the slides after the webinar is finished. I would like to make sure that we are questioning our sentiment in security, that we are understanding that our development teams are under a massive amount of pressure, and yet are still investing in security. And that's a really positive sign in a challenging situation. And it links to what we're going to cover next about DevSecOps and developer productivity. What does it mean for us as security leaders? Firstly, our developers cannot pour from an empty cup, which is, is a cute saying. But what we mean is if you are under pressure, if you already have a full workload, then you're not going to be adding more things in. Now, that means all the initiatives requiring human effort that we're likely to try and roll out this year, 2024, we're going to meet additional pushback. Now, that's not because they don't want to do it. As we said earlier, there is a drive to software quality. But what we are seeing is that they do not have any more energy to give. So whatever you're providing, you need to be making sure that you're capturing and allocating time, allocating resources so that people can understand where they need to go with this and that they have the time to do it. It also means that we've got to be really ruthless with our prioritization of initiatives. So it's really not going to be a great idea for you to kind of casually bring in a new tool or casually bring in a new initiative. You're going to be wanting to make sure that you know which thing you're going to tackle first. It could be that you don't take on a whole AppSec program this year, but you tackle one stream of it. But get to know your development teams, get to know your organization. If it's had a layoff this year or multiple layoffs over the last year, then that's going to affect a lot of these things. You cannot improve security if your team are burnt out. Let's move on to our second topic for the day. So DevSecOps versus developer productivity. So DevSecOps, as you will all be aware, has been around for now about 12 years. It predominantly got its voice in about 2017, though that's when we first all started to hear about it on the mainstream. And as you will know all too well, we've been moving from waterfall, these linear, slow projects measured in months and years, through to agile, which was rapid iteration and releasing in frequent intervals, through to DevOps. Now, the first thing I'm going to challenge here is the idea that all software has moved from waterfall to DevOps. This is entirely not true. Almost all large organizations are a mix of these three methodologies. And even then, their interpretation of those methodologies may be different to each other. For example, the folks writing software in the oil industry, so software that's deployed on oil rigs, are still very much waterfall. They probably have one deployment window per year in which they're allowed to bring new software onto that oil rig. There is no way that they are going to get into a continuous integration, continuous deployment environment. The health and safety of the situation would prevent it. For some of us, we are more in the agile, and that might be new to us, or we might have been doing it for 10 years by now. I'm not here to judge. I'm just here to comment on the fact that your teams within your organization may be different from each other. And one of the most powerful things you can do in 2024 is really understand which team is at what maturity in their software development practices, because that will underpin what you're able to do in your AppSec program. So what is wrong with DevSecOps? I hear you ask. Well, I don't, because you're not talking, I am. But that's the point, right? We want to be understanding what's gone wrong. Why would there even be a push away from DevSecOps? DevSecOps as a movement has a great idea behind it. The idea of collaborating and combining development, security, and operations together with a shared sense of purpose and ownership. However, in reality, it's causing friction, and many of the things that led to DevSecOps in the first place are coming up again. Now, originally, before DevSecOps was a thing, and I was on ops teams back in those days, we had hard segregation between development and operations and later security. Now, with DevSecOps, the hope was that our teams would become full stack responsible, full stack capable, and be looking after this. However, what we're really seeing is the formation of DevSecOps teams, which are often separate to your developers, and they take care of some development, but that is typically development enablement, some security, and some operations. Increasingly, we're seeing this also roll into SRE, so site reliability engineering teams, where DevSecOps is actually being consumed as part of overall site reliability. Now, if you've been around long enough, like me, this starts to feel eerily familiar. This is exactly how security got adopted into operations teams back in the day. Now, does this mean that DevSecOps is wrong? No. It means that we have some cultural and operational challenges that are causing this repeat in the cycle. So, for a start, things like our security initiatives are being very, very tightly coupled to our CI/CD pipelines. And I'm going to come back to that later when we talk about our blind spots in our pipelines. This means that the people who manage those pipelines, who configure them, not necessarily run them, are often the people who are the only ones touching the security tools. So if you've got this case, then you start to isolate your security initiatives away from your active development teams. We're also seeing a lack of prioritization in security initiatives, which is often leading to broken tool chains. Now, to explain what I mean by this, imagine you came into your dev team or your DevSecOps team, and you said, hey, I've got you this new tool. It's a SaaS tool. It's going to run in your pipeline. It's going to tell you the bugs before they go into production. Great. In theory, every part of this is fantastic. But in reality, if that tool runs very slowly, or if its reporting is flawed, or it has a high level of false positives, that's going to be very, very difficult for the team to work with. And so those initiatives end up either in a tool chain and causing friction, or removed from a tool chain and passed to somebody else to do. If any of this is echoing with you, with a situation that might be working in your environment right now, then don't feel bad about this. This is absolutely common right now. So what is happening instead? Well, dev teams themselves are talking less about DevSecOps and more about developer productivity and its more negative terminology, developer toil. Now, developer productivity is the idea that developers work best when they're focused, when they have reduced friction in their environment, and when they can focus on the problems that they're the best at solving. Now, if I'm completely honest, I think we all like being productive and we all hate toil. So I think, I feel for them on this. Now, examples of things that are hurting developer productivity at this moment are things like context switching, inconsistent and changing priorities, poorly functioning tools, poor tool integrations, high false positives, bottlenecks in processes, and lack of empowerment and autonomy. Now, these have some really important relationships with our security programs. Context switching is really, really hard to solve. Are we pulling people into a lot of meetings? Are we distracting them from their work ad hoc, or do they know that our security initiatives are coming and can plan around it? Is our tooling meeting the standard that we're requiring? Do we have false positive rates that are through the roof? Do they need a specialist or a dedicated person to triage? If you have been hiring security analysts in the last year to just triage your DevSecOps tools, you're not alone. A lot of teams have had to do this because of the false positive rate being high, because it is too much of a distraction and a context switch to a development team. Does this mean the development team are lazy? No, they're just very, very time poor, and they have a very low tolerance to bad software. And unfortunately, some of the tools we're rolling out are not great software. They do not have great user experience, and they do not have high quality results. If you have put in a separate process where somebody has to send something out for a security review, or a security process that is outside of their core development pipeline, this comes under toil as well. It's really damaging to our engagement with our development teams when the development teams have to send something out to someone else outside their world, get their homework marked, for example, and get it sent back. So do watch out for that. In the development teams, they are actively talking about how they reduce this. Now, that doesn't mean not doing the jobs. They're spending time figuring out how they can improve these things so that they run smoother, they run quicker, they're less of an impact on their time. This is something important we can bring back to our AppSec programs. If we know that developers estimate that they are spending 20 hours per week to doing things that are, distractions, that are toil in their view, we want to make sure that security is not part of that. We want to make sure that we're minimizing the toil we provide. We're actually making them faster, that we're making it more easy for them to identify and adopt improvements. If we know that it's taking 40 hours on average for them to investigate an incident if it happens, then we are incentivized to have less incidents, not just because of the reputational cost and all of those kind of things, but because 40 hours is a full-time week for a software developer. Now, if you're wasting a whole week investigating one incident, then you're not doing what you're actually employed to do every day, to get that code written, to build those new innovative systems. So we have some really great incentives here for us to be mindful of this push to productivity and to help with it rather than hinder it. So key things to take away from this section. Friction and toil aren't necessarily evil or bad, but there's too much of it at the moment from all corners and not just from security. So when we're introducing new initiatives into our teams, when we are trying to drive up security as part of software quality, we need to make sure we're being mindful and respectful of developer productivity and the impact we have. If what we're asking them to do is going to cause them pain or is going to cause 40 hours of their week to disappear, then we need to rethink. It also talks about the high cultural importance now that is of security. So we can't just say, hey, security is important, you should care about it, go do it, please. We need to be working collaboratively with them. Now, that's what DevSecOps set out to do. But what I would say is instead of shifting left now, we should be looking at a collaborative model. So that means everybody in the team has a little bit of security to do. We call this 1 hour AppSec. So giving everybody responsibility for 1 hour of security effort every sprint. Now, that may not work for your team. You may not even work in sprints, but keep that in mind. Try and kind of measure how much security you're expecting people to do and check that you're giving them the empowerment and the autonomy and the support to do that. So 2 sections down, I hope you're all still with me, and do remember if you have any questions to pop them into the box at the bottom. I am checking in regularly, even if I can't see your lovely faces. So that's talked about DevSecOps and the change that's happening there. And I think the key thing for us to realize is that we can be singularly focused on security. You know, we've come from this world of risk and trying to minimize it. And what we don't often realize is how many other challenges are being dealt with at the same time. So let's have a little talk now about no code and low code in AI. I would love if you are in the call right now and you're able to just put a little +1 in the box if your team are already actively doing something, even if it's just experimentation with no code or low code platforms. I'd love to get a bit of a feeling for that. So throw just a +1 in the box if you can. In this section, we're going to have a look at how these tools are being used and what does it mean to us as security leaders. Spoilers, it doesn't mean we're going to say no to them. So what is low code and no code? Well, for those who already know, I apologize, but just to make sure we're given the same definition each and we're all having a shared starting point. Low code and no code are the Lego of software. They are systems that allow us to take pre-made, pre-built components, put them together and build them into fully functional, complex software systems. Now, this isn't just the edge cases of things like Recode and Bubble, if you've used those or played around with them. Even players like Microsoft and Amazon are actively investing in providing us with no-code and low-code tools that can be thrown into our environment, and we can make sure that they are there and built in as part of what we're doing every day. Now, let's have a look at that. In fact, Gartner says, now Gartner you can take it with a pinch of salt, but you know, it's a stat. They reckon 77% of companies are either using or exploring the use of no code and low code. Now, if you haven't put a +1 because you think it's not happening, I would love for you to go make some friends in the software teams, because you may well find that it is happening and you're just not aware. Now, there's a great case study. Now, I'm sharing these slides afterwards, so you don't need to try and write down the link. But even companies like Coca-Cola are using no-code solutions, powered by Microsoft in this case, to, they estimate, reduce the workload by 10 software engineers. So they've estimated that the product that they've rolled out using no-code took 1/10 of the engineering effort to to build in the first place and then to ongoing support. Now, what does this mean? Well, it can mean a few things. A tenth of the workload is interesting in a climate where a lot of layoffs are happening. Do not be surprised if leadership teams are making decisions to reduce headcount if they are embracing low code and no code environments. Secondly, there's a complication with using this kind of system that may mean that we have some challenges in security later. I'm going to cover that now. These systems are not simple. So many of us, when we think of no code or low code, we think of a CMS system. You know, I'm going to build a new website and I'm going to use some kind of content management platform. I'm going to throw some components together and I have a marketing website. Great. This goes far beyond marketing websites. We're talking about fully functional data storage, capture, and processing systems that are built with a few clicks. They can have authentication, they can have multiple roles and authorization systems, they can use single sign-on, they can connect with third-party integrations. Now, these are complex systems, and most importantly, they're inheriting the complexity from an external provider. Now, yes, it's great that Amazon and Microsoft are providing these tools, and that can mean that these things are at a different level of maturity than other startup companies. However, it doesn't necessarily mean that. As a security person, this means our third-party assessment of risk gets very, very complicated. It's not the case that we know our team has done pull requests for every change they've done. It could well be that our team is not able to do pull requests in the same way. They can't review the code that's being built anymore because it's being built from these pre-made components. Also, if we look from an attack point of view, if you're an attacker, you're fundamentally quite a lazy person. And by lazy, I mean quite efficient. You're going to be looking for targets that have a high surface area, a large number of people using them that you can then try and exploit. Now, as we've seen with WordPress, where WordPress is used by literally hundreds of millions of websites all around the world, and therefore is a very high profile target for attackers, even though it has a huge security team and a huge security focus, it still struggles keeping up. Now, if no-code and low-code systems continue to grow, we will absolutely see our attackers targeting them more and more, because for every no-code and low-code platform that they are able to attack, they're going to be able to achieve compromise of a much larger number of organizations. This is exactly the same way that we've been thinking about our things like our API gateways for the last few years, where as an attacker, it's much more cost effective to attack your API gateway or your CI/CD pipeline than it is to attack an individual custom application in some cases. So let's talk about AI. I'm going to ask the same question again. If you're using AI in your systems already, +1. If you are horrified and hope you're not, but you don't know, then I'd love for you to, show your horror in some way. But for many of our teams now, and I mean almost all of them, AI is already in our systems, whether we like it or not. It is being used as a productivity assistant using ChatGPT and GitHub Copilot, just to name just two. We have it as part of our third-party integration. So if you look at the changes in terms and conditions in organizations like Stripe, Auth0, and other SaaS providers in the last few months, almost exclusively, they are now upgrading their terms and conditions and stating that AI is in use somewhere in their platform. It may be part of your code if you're building an internal capability or model. Or if you're not using it internally at all, your attackers certainly are. And I think this is a really important thing for us to factor into our application security programs. It is not the case that we say, no, we're not doing AI. It is the case that we need to look at everything from the development tools we use to build our code, the third-party systems that we integrate with. Primarily, I'm talking about SaaS platforms here and those platforms that we directly send traffic to and from rather than the libraries we integrate with, but watch this space for how that develops. And then what you're doing internally. Now, it could be that your AI internal development is currently restricted to innovation spaces or experiments, but that may well change with time. So you need a strategy for this. You also need to know that your attackers, as always, are going to adopt DevSecOps and development tools as quickly, if not more quickly, than your team will. Just as we saw in malware and in phishing campaigns where they use DevSecOps templates and techniques to roll out phishing campaigns in just minutes rather than having to build them by hand, they now just use Terraform like we do, and they roll out our applications on demand using a CI/CD pipeline. Our attackers are using AI for the same purposes. They're using it to write the custom scripts that can attack our websites. They're using it to iterate over large data sets and spot patterns. They're using it to help support things like cracking passwords and planning attacks. So I would love for you to start thinking about this in your threat models. As security leaders, we cannot say, hey, AI is coming later. It is already here. If you haven't already checked it out, the OWASP LLM, so the OWASP Top 10 for LLMs, is now actively out there. And as of last week, the OWASP organization has also released a governance guide for AI and LLMs, which you may find useful from a more management and strategy point of view. What does this mean for AppSec overall? Well, the one thing I want to talk about is threat modeling. It's the one part of this that is really going to change, and very, very rapidly. Now, let me explain. In your current systems, when you do a threat model, you throw it on a whiteboard like this. You've got some boxes thrown together with some lines, and you're looking at the flow of data and interactions through your system. Now, in most cases, in a standard non-AI backed system, if you insert an apple into your system and it goes through the same 3 steps every time, you will know that there's an expected result. For example, an orange comes out of the other side. In an AI-based system, as we know, those middle steps can evolve as the model changes, as the model learns. And that means that the steps that we expect to happen to our apple, to our input, may be different, or the decisions that the model has made may vary with time, which means that we can't do a linear stack review anymore. We cannot look at our threat model as a static thing. We need to understand how the logic is going to change in our system's behavior, what visibility we have of it, and what explainability we have of that. Now, explainability is a huge and upcoming trend in AI software development. There is law coming into force in Europe that requires AI-based algorithms to explain their findings. It's kind of like the maths test you did as a child, where you had to show your answer and how you got to it. This is the same thing. Now, the reason for this push is no system should be opaque. No system should be able to operate where we cannot understand how it made its decision. And so there is law being pushed through in more progressive environments right now to back that up. Now, if you're in the privacy space, in finance, banking, accounting, insurance, you can guarantee in the next 12 months, you're going to need to make your AI systems explainable. And as part of that, you're going to be looking at the threat model of how that works. So there's a lot of work needs to be done to make threat modeling something that is more suitable to an AI environment, and to actively call out any gaps you have in your assessment if you're making assumptions about an AI model being linear or non-changing. Right, our final section for today. So if you are thinking about any questions and you do want to start putting them in the chat, please do so. Happy to answer them at the end. Or if you reach out to me directly afterwards, I will follow up. Let's talk about the blind spots in our pipeline. So far we've had a look at the health check of our dev community, and we've seen a system under pressure. We have looked at DevSecOps and why that is migrating more to a view of developer productivity and what we can learn about that. And we've taken a very high level look at how no-code, low-code and AI are starting to come into our space. And now let's have a look at our blind spots in our pipeline. Now, one of the things that's come out of our reviews with a great many software companies is that, yes, we are doing application security, but our application security focus is singular, and it is a limited parts of our software development lifecycle. And this has been going on for quite some time. So our focus at this point is still limited to implementation, testing, and deployment. Now, about 10 years ago, we'd have looked at this diagram and it would have just had penetration testing in it. So we have made a lot of progress. I'm not going to understate that. But what we're seeing now is we're putting in tools like SAST and DAST. We're putting in capture the flag exercises. We're putting in tools into our DevSecOps or CI/CD pipelines. But they all happen after the code has been built. We review the code once it has been made. We test the code after it has been made. Now, as software development is much more than these 3 stages, one of the biggest things you can do for 2024 is expand your focus. If you're doing no-code and low-code, for example, implementation and testing may not actually apply in the same way, but idea and design definitely do. So does maintenance. If you have a broad team, including analysts, architects, and UX folks, there are opportunities you could be taking to bring your threat modeling and design much, much earlier in the piece. We also need to be looking a lot more at maintenance of our software. While we do actively write millions of lines of code every single day, there are hundreds of millions of lines of code that are never touched anymore, but are still in production environments. And we spend very little time looking at those. If you are running all of your controls in implementation and deployment, they're all actively in your CI/CD pipeline, you are not looking at any of the systems that are not currently being built. If you have a system out there that hasn't been built in 3 years because it just does the job, then I can guarantee you two things. I can guarantee you it doesn't use CI/CD technologies. I can guarantee you it's using out-of-date third-party components, and they almost certainly can't be updated. Now, that can't is a very intentional word. We often in security say that the solution to third-party risk is, automatically generating pull requests and making sure we update our dependencies. But in some of our systems, updating a dependency is moving several versions forward. And that is not just a security change, but normally a breaking functional change. And unless your team has allocated resources and time to fixing those changes in the functionality, they will not change that item. Now, one of our biggest problems is supply chain. We know that we've been talking about it now for 2 years. And so if you're going to take some actions away from this section as a security leader working with dev teams, please know the following. Legacy and foundation systems run the internet. It's not just our new stuff. And our development teams know this, and they worry about those old systems, but they're only given time and resources to work on the new stuff. As security leaders, it's our job to make sure those software development teams are given the time and support to look after all of the software we build and maintain, not just the new stuff. We also have to have a plan in place for software that cannot be updated. Now, that doesn't mean go and buy a new web application firewall for most cases, but you do need to acknowledge it. And it's not the case that developers are lazy or they don't want change. It could be that that change is far more substantial than we make out in our brochures and our marketing within security. We need to look at data for its full life cycle. Now, there's some interesting case studies out there at the moment of where data is going through systems and then being used by other systems much, much later and exploiting those later systems. Remember that our data lives for a very, very long time. We often have minimum data requirements or minimum data retention requirements, but not maximum. And so if you know you don't have a maximum and data could exist in your systems for a very, very long time, 2024 could be the year to really review that. The best solution to securing your data has always been to have less of it. And this is a good reason to do that. Finally, think about those systems that are under support still. So you still have to look after them, but they're not under active development. Because it could be there's a few risks that are emerging that you may not be aware of. That could be things like key person risk, where nobody knows how that system even works anymore. It could be things like outdated technologies. It could be that the system, the infrastructure itself is hosted on, has just gone through a change. If you've been watching the situation unfolding with VMware and the changes to their licensing, this is going to impact security. If you have to move systems from something like VMware to a cloud-based system in a hurry, and that system is a lot older and a lot more fragile than your new code, there is security risk in this. So please consider it. So what do we need to do? Well, as AppSec people, our developers are hurting, and we need to support them more than ever. They have a lot to do. They have less people and less budget than they ever had. The solution is not to buy more tools, it's to look at what we've already asked them to do, the friction that it's causing and the impact on their world. And if you are able to make improvements to reduce developer toil, improve productivity, then you're going to make a lot of friends and make a cultural change that no tool can do on its own. I'd like you to be really open with your dev teams and understand where AI, no code and low code are already happening, and be open to having the discussion about how your security techniques might need to change for these new technologies. I hope you found this interesting today, and thank you for spending 40 minutes with me as we went through it. I'm just going to check in on the questions. So we've got a great one here from Michael. What else would you introduce besides threat modeling in the design architecture phase to extend the security lifecycle? So design and architecture. Firstly, I think I'd love us to break down threat modeling a little bit more. So threat modeling can mean a lot of things. It can mean a big formal process if you have an architecture team and have been doing a more formal security architecture approach. Or it could mean that you're having informal gatherings with a whiteboard and people working on a new change to think about it in an evil way. I would love to see the threat modeling stage linked to the creation in advance of security tests. Now, this could be your QA folk, it could be your developers, it could be the development of a Cucumber style set of reusable test wordings that explain how you would test for the threats that you're identifying. But the trick is to make that threat modeling very dynamic, continuous, and to make it safe so that everybody can get involved. There's some really interesting work going on with UX at the moment of how they can psychologically influence our users to behave in certain ways and improve security. So I think as that matures out, you'll be able to bring in much more visual approaches to your threat modeling and the solutions you come out with, and not just the code stage. So that's what I'd start with. The other thing is we threat model a lot of the systems in our active development. Maybe every few months, pick up an old system, a system that hasn't been used for a while, where the institutional knowledge is fading a little bit, and see if you can reverse engineer it, see if you can understand what it's doing, and maybe use that as a part of the start of a threat model as well. Are you working on that system? Can you make changes right now? Probably not. But at least you're gaining more institutional knowledge, identifying risks, and creating a little bit more stability in the team. Right, that is all the questions we've had for today. Thank you so much for joining, everybody. I hope you found that useful. We'll continue to do these kind of updates, trying to share what is currently happening in software development land and why it matters for us. Because remember, application security only exists because software development exists. Without our software teams, we're nothing. We don't exist at all. So the best thing we can do is be the most open and constructive supporting cast that they need, and be really mindful of the impact of the initiatives we try and roll out, especially in 2024, where resources and stress levels might already be high.